today we're going to be talking about right triangle proportions. So we're going to be talking about the proportions that are formed when we have an altitude drawn to the hypotenuse of a right triangle. So if you take a look here, we have a right triangle. But then we have an altitude that's drawn down to my hypotenuse. So let's label the parts of the triangle that are formed when this happens. So this whole thing right here, we know is the hypotenuse. Now, the hypotenuse is then split into two segments. So we have a segment from A to D, and then we have another segment from D to B. Now we know this is the altitude, because the altitude was drawn to the hypotenuse. And we know when we have a right triangle, we have legs. So this is a leg, and this is a leg. Because again, it's really one big right triangle. So, when we solve questions involving altitudes drawn to the hypotenuse, there's two situations. We have what's called hills, and we have what's called SAAS. So, let's talk about it. I'm going to redraw a right triangle right here. No, that's not like that. Okay, so again, here's my right triangle. Here's my right triangle, and my hypotenuse is drawn down there. So hills is when we have the hypotenuse there we go. So it's when we have the hypotenuse, and it's when we have a leg, doesn't matter which leg, and a segment. So when we have hills, it's going to be, the proportion will be hypotenuse over leg equals leg over segment. Now keep in mind, when we have leg two times, it's going to be the same leg. It's going to be the same number. So this will end up being the same number. Okay, so when we have SAAS, so again, we have a right triangle with an altitude drawn to the hypotenuse, and we know an altitude forms right angles. So SAAS is if we have a segment, we have two segments, and we have an altitude. So I like this one because you can go like this. You know, you can do a loop-de-loop. Okay. So when we have SAAS, your proportion is going to be segment over altitude equals altitude over segment. So again, these will be the same number. Or if it's X, they're both going to be X. So let's take a look at an example. So example number 1, if AD is 3, CD is 6, find DB. So when it says find, you want to make sure you put your X there, so this way you know what you have. So I know I have an altitude. Since I have an altitude, I'm going to be using SAAS. So again, segment over altitude equals altitude over segment. So segment over altitude equals altitude over segment. So we have 3 over 6 equals 6 over X. See, if you notice, 6 and 6, we said they're going to be the same. All we do now is cross multiply. So 3 times X is 3X. 6 times 6 is 36. So now we know how to solve. We divide by 3, x equals 12. So that means that your segment DB is going to be 12. That's it. That's all we have to do. I'm going to do one more with you just to show you an example of when we have hills. So if AC is 10, AD is 5, find AB, that's this whole thing here. We know the whole thing is the hypotenuse. So we know this is the segment because it's the segment that was created when we dropped that altitude down. We have our leg and we have our hypotenuse. So if we remember from the top, our proportion is going to be hypotenuse over leg equals leg over segment. So my hypotenuse here is x. My leg is 10. So that goes twice. And my segment is 5. Now, I just want to point out that sometimes they're going to give you, two segments to confuse you. Or they might give you the hypotenuse and one segment, and you have to find the other segment. Keep in mind that the leg that you're using and the segment that you're using, they have to be in the same triangle. So if you notice here, we have that now because here's my triangle and my leg and my segment are in the same triangle. If you had, let's say, your segment over here, let's say this was 5 and this wasn't here, you couldn't use your segment being 5 because it's not in the same triangle. So just keep that in mind. There might be times where they'll say, okay, the hypotenuse is 10, this segment is 3. So then you have to find the other segment by subtracting before you actually have the correct segment. So just keep that in mind. So we have 10 times 10 is 100. 5 times x is 5x. So we have 5x equals 100. Divide both sides by 5. So x equals 20. Therefore, segment AB is going to be 20. And that's it. Those are our right triangle proportions, also known as hills and SAAS.